Hi everyone, this is your struggling CS student. Today I'll be doing the weekly premium LeetCode problem. So let's take a look at today's problem. 1427, perform string shifts, okay? So you're given a string S containing lowercase English letters and a matrix shift, where shift of I is the direction and the amount, okay? Direction can be 0 for left shift, 1 for right shift, and amount is the amount by which a string S is to be shifted. Okay, so left shift by 1 means to remove the first character and append it to the end. Remove the add it to the beginning, return the final string after all operations. Okay, let's see. Okay, you shift left by 1, 0. So, okay, shift left by 1, BCA. Yep, correct. Then you shift right side by 2. So that is BCA, right side by 2. Oh, okay, right. So actually, as you can see, the way what immediately comes to mind is to use a double-ended queue, and you can just simulate the problem and you should be able to get the result. So let's do just that. From collections, import dq, and q is equals to dq of s, and we'll say left, oh, left equals to 0, right equals to 1 for direction amount in shift if direction is equals to left, else. And what we need to do is, oh, actually, what's the shift operation? Shift, oh, the direction can, amount is, I see. So actually, with the idea that I have is basically to do a simple simulation, and you can see that the time complexity would be amount times s of length. Because, for example, you can think of a case where every shift is the max. Every time you're shifting 100 times, and let's say there are um, how many shifts are there? There are 100 shifts, right? So there will be 100 times 100 in the worst case. There's probably a smarter way of doing this where you can just calculate the final position of each of the elements, but I'm not going to do that because I'm lazy. In an interview, if you want, you can probably absorb this, but the simple way would be to just do a simulation first. Maybe I will try the absorb solution later. Yeah, we shall see. Okay, so if direction equals to left, then for times and amount and range of amount, then you would do q dot pop left, q dot append, q dot pop left. Else, for times and range of amount, this is where we're going to the right side. So q dot pop, q dot append left. Oh, append left, q dot pop. Then you can return not join q. Yeah, this is the simulation solution. Let's give it a quick submit. Accepted. But let's try to absorb this, right? Because the time complexity for this would be let's not look at a tutorial, but the time complexity. This would be, yeah, if is shift times amount, and then the space complexity is OS. It's OS. Linear. No, there's no way, man. Yeah, I don't think that's right. But let's see if we can absorb this. So every time we, instead of performing the actual operation, we can calculate the final position. But we need to calculate it for each character. That means we probably need the length. is amount, the final position. Can we calculate the final position? Yeah, of course we can. So you shift by 2. Oh, wait a second. Oh, it'll be shift times shift. No, shift times S. I see, okay. For IC in numerator of S, we still need to calculate the final position for each of the strings, each of the character in the string. Else, then like that. We don't need LeetCode anymore. We can just use back S. So 10 is equals to times n. That one's good. And then we need to calculate the final position for each of the characters. So, some sort of modulus operation for sure, we would say temp of I to the left minus amount mod n is equals to C. Something like that. Plus amount. Maybe we need to do a +1, but yeah. It's wrong. ABC. Join of, oh, we didn't assign s equals to 10. S equals to 10. Okay, maybe it's not that bad after all. Yeah, it's not that bad. But then the time complexity would be shift times S. Shift times S, yeah. What's the time complexity here? It's linear, really? I don't believe, man. Let's take a look. Yeah, first one, simulation. We actually do the operation and then the time complexity. Let's take a look at what LeetCode says. N times L, where L is the length of the string, N is the are you doing the modulus operation? Huh, interesting. Compute net shift. Is this actually the O plus L? Oh, interesting. I think this is more on the medium side. Probably not. Oh, I see. Well, that's actually pretty smart. That's pretty smart. Okay. What they're doing is they are pre-processing the shifts first, right? Then they calculate the final position. For example, here you're moving left to 1 and you're moving right 2 times. This means that in essence you can just take the final string and move it right once. Oh, okay. And that's pretty smart. Let's see if we can adapt our solution to that. So, how should I do this? For direction, amount, and shift. Actually, we don't need to delete this code, maybe we need to reference it. What you're doing is final shift, I guess. It's equals to 0. So if the direction is equals to left, then you take final shift minus equals amount, else final shift plus equals amount. Then for each of the characters, you just shift it by the final amount. Oh, that's pretty smart. Yeah, it is pretty smart. We can do this. For IC anyway, as I plus final shift. Oh, okay. Well, learned something new today. So you process the shifts first, compress it, and then you apply the shift. That's smart. Okay, that's all for me today. Thank you for watching and Happy New Year.